Welcome to Knowledge Through Quizzing. This is the world of mathematics number 1. I hope you enjoy this quiz. Do like and subscribe to this channel for more quizzes on interesting topics. Let's get started. Here's your first question. Which ancient Greek mathematician discovered that the square root of 2 is irrational, but according to legend, was drowned at sea by Pythagoreans for revealing this dangerous knowledge? The proof supposedly threatened their belief that all numbers could be expressed as ratios of integers. The answer is Hippasus of Metapontum. He made this discovery. The story of his death, while probably apocryphal, illustrates the revolutionary nature of irrational numbers. Here's the next question. What ancient Greek mathematician ran through the streets shouting Eureka after making an important discovery while taking a bath? The story goes that he found a way to determine if a crown was made of pure gold by measuring its displacement in water. What was the name of this principle he discovered? The answer is Archimedes' principle. The principle states that a body immersed in fluid experiences a buoyant force equal to the weight of the fluid it displaces. Here's the next question. In the late 19th century, a mathematician revolutionized set theory by proving a groundbreaking theorem about infinite sets. His theorem states that for any given set, the power set, the set of all subsets, always has a strictly greater cardinality than the original set. This means even for infinite sets, there are different sizes of infinity. What is the name of this theorem? The answer is Cantor's theorem. The theorem is named for George Cantor and is a fundamental theorem in set theory. Here's the next question. Leonardo da Vinci was fascinated by a special number sequence where each number is the sum of the previous two numbers, 1, 1, 2, 3, 5, 8, 13, 21. This sequence appears surprisingly often in nature, from flower petals to pinecone spirals. What is this sequence called, and who first discovered it while studying rabbit populations? The answer is the Fibonacci sequence. It was named after Leonardo Fibonacci. He discovered it in 1202 while calculating how rabbit populations might grow under ideal conditions. Here's the next question. Which mathematical symbol was missing from early mathematics, making calculations much more difficult? It represents nothing, but it's actually one of the most important mathematical innovations in history. Which ancient civilization is credited with inventing this concept? The answer is the discovery of zero by the Indian civilization. The ancient Indians are credited with developing zero as both a placeholder and a number. Here's the next question. Which simple puzzle game invented by a Hungarian architect became one of the world's best-selling toys? This cube can be twisted and turned in many ways, and while there are billions of possible combinations, every scramble position can be solved in 20 moves or less. What's its name? The answer is Rubik's Cube. Ernst Rubik invented the Rubik's Cube in 1974. The world record for solving it is under 4 seconds, though most people take much longer. Here's the next question. Which number is considered the golden ratio and appears in art, architecture, and nature? The ancient Greeks believed it to be the most aesthetically pleasing proportion, and it's still used in design today. What is this number? The answer is 1.618, also known as the golden ratio. It is special because, when you divide a line according to this proportion, the ratio of the larger part to the smaller part equals the ratio of the whole line to the larger part. Here's the next question. Which mathematician in the 1950s developed a theory of games where players could cooperate for mutual benefit, contradicting the prevailing view that game theory only applied to competition? His work revolutionized economics, but was initially rejected because it challenged existing mathematical models of rational behavior. The answer is John Nash. He developed cooperative game theory, and his work on non-zero-sum games revolutionized economic thinking. Here's the next question. In the 1960s, which mathematician discovered that simple mathematical rules could produce incredibly complex patterns, leading to chaos theory? He found this while using early computers to model weather patterns, noting that tiny changes in initial conditions could lead to drastically different outcomes. The answer is Edward Lorenz. He discovered chaos theory while working with weather models. His work led to the concept of the butterfly effect. Here's the next question. When folding a piece of paper in half repeatedly, each fold doubles the thickness. A typical piece of paper is about 0.1 millimeters thick. How many folds would it theoretically take for the stack to reach from Earth to the Moon, about 384,400 kilometers? The answer is surprisingly small, showing the power of exponential growth. The answer is 42 folds. It would take only 42 folds to reach the Moon. Of course, it's physically impossible to fold a paper this many times. Here's the next question. The number 1729 is famously known as the Hardy-Ramanujan number, after an anecdote involving G.H. Hardy and Srinivasa Ramanujan. It is the smallest number expressible as the sum of two cubes in two distinct ways. What is the general term for numbers that can be written as a sum of two cubes in at least two different ways? The answer is taxicab numbers. When Ramanujan heard that Hardy had come in a taxi to visit him at the hospital, he asked him what the number of the taxi was. Hardy said that it was just a boring number, 1729. Ramanujan replied that 1729 was not a boring number at all, it was a very interesting one. He explained that it was the smallest number that could be expressed by the sum of two cubes in two different ways. Here's the next question. A famous paradox in probability theory involves a game show where a contestant picks one of three doors, behind one of which is a prize. The host, knowing where the prize is, opens another door to reveal an empty space. The contestant is then given the option to switch or stay. Many find it counterintuitive, but switching actually increases the chances of winning. What is the name of this famous probability puzzle? The answer is the Monty Hall problem. This problem is extremely counterintuitive because our statistical assumptions are incorrect. This World of Mathematics quiz number 1 was brought to you by Knowledge Through Quizzing. I hope you learned something new today. Keep coming back for more quizzes on interesting topics. In the meantime, don't forget to like and subscribe to this channel.